Okay, so welcome back to another video of this 5-a-day GCSE series. This is, I think, yeah, this is 9th of Jan, and this is grade 8, grade 9 questions that we're working on. First question is from laws of indices, pretty easy. So first we're going to do the numbers together. So 18 over 6, that becomes 3. Now we've got x to the power of 5 over 4 over, if that's x, that is x to the power of 1. Laws of indices, we're going to subtract the powers, so that's 5 over 4, take away 1. So I tend to multiply that, so that will be 5 over 4 minus 4. Keep the common denominator, which is 4, so that will be 1 over 4. So my final answer would be 3x to the power of a quarter. Excuse me. Second question, find the equation of a straight line which is passing through two given points, and then you need to give your answer in the form of ax plus by plus c. So whenever you want to find equation of a line, remember we need two ingredients to make the equation of a line. One, we need the gradient. Two, we need a point. We know the answer that we're going to work towards is going to be y equals mx plus c. M could be found out by y2 minus y1 over x2 minus x1. In other questions, you can either use parallel, perpendicular conditions as well. Here, we're going to do y2 minus y1, so that's 8 minus 0 over x2 minus x1, which would be minus 2 minus 1. So I've got 8 over, sorry, this should be a minus 1. So I've got 8 over minus 3. Okay, so this was y2. X2, y1, x1. So yeah, I think I've done that okay. So I've got the gradient. Now I need a point. Now you are free to choose either of them. I'm going to choose the 1 and 0 because I like those numbers better, 1 and 0. So in place of the gradient, we can now plug in 8 over minus 3, which means I could replace this and write 8 over minus 3. Now to find out c, I'm going to have to plug in x as 1 and y as 0, which means y becomes 0, x becomes 1. So I now have 0 is equal to 8 times minus 3, so that's going to be, now even if you leave the minus with the 3 or with the 8, it still doesn't make any difference. So okay, I'm going to leave this here and then plus c. Now when you move the 8 over minus 3 to the other side, that becomes 8 over positive 3 because the negative goes away, and you have c is equal to 8 over 3. So that means I can now write the equation as y equals, I'm going to write minus 8 over 3 because it'll make my life easier. Again, I want you to remember, even if you do 8 over minus 3 is the same as, because some people tend to, and this is also the same as if I put a minus in the middle. So if you're getting confused there, it's still the same thing. All of these are equivalent. This is equal to x plus, and this would be 8 over 3. Now, I do not want the denominator, so I'm going to try to get rid of the denominator. So I'm going to multiply everything with this denominator. So I'm going to multiply by 3, multiply by 3, multiply by 3. What happens is when you do the multiplication, the 3 and the 3 gets cancelled off, 3 and 3 gets cancelled off. So you get 3y equals 8x and then plus 8. So if I have to, it would be easy if I move the 3y onto the other side because I can get the 0 here. So that will be minus 8x minus 3y plus 8, and that is equal to 0. Let me show you something else. Let's say if the question was y equals minus 8 over 3x plus, let me try this as 8 over 4. Now the problem is I would want to get rid of 3 and 4 at the same time. So if I want to kill two birds with the same stone, I would look for the LCM, which means I'm going to multiply this with the 12. and I'm going to multiply the other side also with the 12 in addition to the 12y with the 12. The good thing is, by doing so, the 4 can divide the 12, giving me a 3. That 3 with the 8 would give me a 24, so I have got rid of the denominator. The 3 can divide the 12, giving me 4, so this now becomes, sorry, that 4 would then multiply with the 8, giving me minus 32x. On the other side, I have 12y. So if you have two different denominators, look for their LCM if you are looking to get rid of the denominator at the same time. This is a completing the squares question, but the problem is we've got a 3 as the coefficient. So we've got 3x squared plus 12x plus 13. What I'm going to do is I'm going to kick that 13 on the side. I'll bring it back later. What we like x squared just by itself. So what I'm going to do is I'm going to factor out the 3. How am I going to do that? Divide the 3, divide the 3. Whatever you divide, leave that outside of a bracket. That's a basic technique or the principle of factorization. Whatever you're dividing with, leave that outside, and your answer should be on the inside. So I've got this. Remember, the 13 is still outside there. Now, I know how to complete the square for this one. That's easy. This would be x plus half that, which would be 2. Now, take this number, square it, and then subtract it outside. So that would mean a minus 4. And you have to pay attention. All of this is done in that same bracket which had 3 on the outside. Should have put a red thing there. So I hope this makes sense. Yeah, so all I've done is take that purple or the blue thing, and I've kind of completed the square on that one. Now what we're going to do is we're going to multiply, or we're going to bring back the 3 to the x plus 2 squared and also to that number, because we're trying to expand the brackets back in place. So now I would have 3 lots of x plus 2 squared minus 3 lots of 4, so that becomes 12. But remember, we still had that plus 13. So we're going to bring back that plus 13. So my final answer would be 3 lots of x plus 2 squared plus 1. And that would be our final answer. So all you have to do is kick that 13 away. What we do here is what we call as a partial factorization, because we're not factorizing everything, we're just factorizing the first 2 terms. Keep the 3 on the outside, complete the square, expand the bracket, and then finally bring back the 13. Got another question from vectors. So first question is, find the vector OB in terms of A and B. So I need to go from O towards B. So first I know that AB is 2A. So let me draw an arrow there to kind of show that AB is 2A. And I know A to O is 6B. So what I have to do is I have to go from O to B, and in vectors all you have to do, remember, is you always tend to go around. You're not going in a straight line, you're going around. So that means I have to go from O to A and then from A to B. So we are going around. Now you have to pay attention to the arrows. Going up would be a 6B, which means if I go down, I am collecting a minus 6B on my way down. So that's a minus 6B. And then as I am moving from A to B, I am collecting a 2A, which means now I know that the vector OB, or O to B, is minus 6B plus 2A. Just to make it neat, we will write A first and B second. So that's going to be 2A minus 6B. Q is the midpoint of OB. So we know this is halfway. B is the midpoint of AC. So B is the midpoint of AC. So I know if B is the midpoint of AC, then this also has to be 2A. Show that PQC is a straight line. Now, if you want to show something is a straight line, so let me say we have P, Q, and C. If you want to show, this is a basic technique in vectors, if you want to show 3 points that make up a single line, it forms a straight line, you take the first two pieces and you show that PQ is parallel to QC. So first let's find what is PQ. Okay, so PQC first let's write what exactly is the line PQC. Do I know anything about P? I don't know anything about P, do I? It's going to be a bit of a tricky one. Let's see. But let's use a different color. So this is the line P to Q to C that we are trying to figure out. Okay, so first let's find P to Q. Again, we have to go around. If I have to go around, oh, they've given us a ratio here. I forgot, I didn't see that. So AP to PO is 2 to 1. That means this is 2 parts, this is 1 part. So altogether 3 parts. So the first, this is 2 out of 3, that is 1 out of 3. Okay. So first I would have to, yeah, I can go up. So let me hide this. First let me draw which way I am going. So I have to go from P to Q. So first I am going up, then I am going down, P to Q. Now you could also go the other way around, but that would involve 3 pieces. I always like the less distance, less calculations. P to Q. P to Q we know is 1/3 of the full vector, which is 1/3 of 6b. So 1/3 of 6b is going to be 2b. Okay, so this part here, which I am going up, is 2b. Now, coming down, I know that is half of OB. And I think I've found out what is OB in part A. So if this is OB, I need to take half of OB on my way down. So half of 2A is A, and half of minus 6B would be minus 3B. So if I collect everything together, I have collected a 2B, I have collected a A, and I have collected a minus 3B. So I can say PQ altogether is A minus B. So I've got PQ, which is the first step. So this is A minus B. Now I have to find QC. So if I have to find QC, I'm going to go Q to B, okay, then I'm going to go B to C. B to C is easy because I know that is 2A, so I've got that part ready. Now I have to find Q to B, and we know Q to B is half of O to Q, and we did find that half of, it is half of OB. So half of OB, just like how we found earlier, so half of OB is going to be half of 2A minus 6B. So the OB part would be again A minus 3B. Obviously, OQ and QB are the same thing. So whatever answer you got earlier for the OQ part will be the same as what you get for the QB part. So what are we doing? Yeah, we have to find QC, right? So QC is equal to A minus 3B plus 2a. So that is equal to 5. Sorry, that is equal to 3a minus 3b. That is 3a minus 3b. Okay, so we have found PQ and we have found QC. So what we're going to do is we're going to divide PQ over QC. This is not proper vector division. What we are doing is we're merely dividing the coefficient. So a minus b, and this one would be 3a minus 3b. So think about it, there is an invisible one here, invisible one here. If you do the division for these two numbers, you would get 1/3. If you do the division for the next two coefficients, that would also be 1/3. So we can say PQ over QC is equal to 1/3, or PQ is equal to 1/3 of QC. That is sufficient to prove that PQ is parallel to QC, and because Q is common, there is only one way that can happen. PQC is a straight line. It is slightly long, but you will get the hang of it once you practice it a bit. So that is the basic logic. I'll see you in another video tomorrow. Take care. See ya. Bye.